Consider x is a normal distribution with a mean of 10 and a variance of 9. And remember, that means the standard deviation is 3. We're going to look at finding these probabilities on this Casio calculator over here. So we're after the probability that x is greater than 12. So I want the statistics menu, so I'm going to go in there. And then I want distribution, which is the 5th thing in the list. So I'm going to press F5 and then normal. So I'm going to press F1. Now, x is greater than 12 is a normal CDF, which is option number 2. I'm going to be doing this for variable, which is option 2, which I was already in. So my lower value here is 12 because I'm after greater than 12. So I'm going to enter 12 and then execute, which takes me down to upper. Now, upper really goes on forever. So what you really need to do is just put in a suitably large value. So if I put in something like 10,000, there's going to be very little probability after 10,000. And we'll execute. My sigma, of course, is 3. And my mean is 10. And so if I just execute again, it gives me the probability 0.2525. So 0.2525. Now I want the probability x is less than 7. So if I go to menu, and if I go straight into stat again, then I'm back where I was. So I need to press exit to take me back to here. And then I'm going to put in a lower value. This time, remember, x is less than 7. The mean is at 10. Less than 7 is going to be down here. So it's the lower end that I need to set as some very small value. Let's go with negative 10,000. That should be plenty. And then the upper, of course, I need to set that as 7. Sigma is 3. It is already in there because we've used it before. And the 10. And so I get 0.1587. So now I'm going to go between 9 and 12. So I just need to exit to go back to the previous screen. I can use the arrow to get back here. And between 9 and 12 means my lower needs to be 9. And my upper needs to be 12. Mu is 3. Mu is 10. Sigma is 3. And so I get 0.3781. Giving all these answers to 4 decimal places. Now finally this one, we know the probability of A given B is the probability of A and B divided by the probability of B. Now in this case, the probability of A and B is probability of being greater than 12 and greater than 11, which is just the same as being greater than 12. That's where both conditions exist. So this is basically going to be x is greater than 12 divided by x is greater than 11. But I might need to keep a few more decimal places, and I should perhaps have done that when I did part A. Anyway, let's bring the calculator back in, and once again we'll exit to go back to here. And so let's go for my lower as 12. Again with the upper, just make it a big value. 10,000 would be adequate. Same standard deviation and mean. And this time I'm going to keep 0.25249 25249 and then we need to work it out for greater than 11. So we'll exit. We'll go back there. We need to change that to 11. Leave all the other values where they were. 0.369, 441. And then rather than come out of the stat mode, I've just picked up my ordinary calculator that won't do that type of statistics. And I've got 0.252493 divided by 0.36941. And that gives me, to 4 decimal places, 0.6834. So 0.6834.